This video is going to go over how to run sample experiment GE1, a GNU Radio-based OFDM transmitter and receiver. At this point, it is assumed that you are already able to access your experiment nodes. On my screen, I have access to two nodes needed for this experiment. Node 1 here on the left, it will be the transmitter, and node 2 here on the right will be the receiver. The first thing we're going to do is we're going to navigate to the radio folders where all of the scripts for the experiments are located. Next, we're going to copy the appropriate transmitter script into the start radio script on the left. Then, we can do the same on the right with the receiver script. Now let's take a look at the configuration parameters that we can modify for this experiment. To do this, we're going to go into the helpers folder, and we're going to find start OFDM TX and start OFDM RX for the two experiments. Here we can see that the two files are pretty similar with the configuration parameters that we can modify near the top. The first option we have is the sample rate, which by default is set for 1 megasample per second. Second, we have the frequency for the experiment, which is 3.5 gigahertz. The args parameter is used for the device arguments, which are not going to be necessary in this case, but may be used for deciding which radio you may want to use. The gain corresponds to the amount of output power that is used on the transmitter and receiver, with the transmit experiment corresponding to transmit gain and the receiver experiment corresponding to receive gain. Next, we have the modulation that can be used for this experiment. This experiment supports BPSK, QPSK, and 16 QAM. These can be changed by modifying the mod parameter to 2, 4, or 16. By default, we're going to keep it at 4 to use QPSK. The last parameter option we have is the duration of the experiment. This number is measured in seconds, so we will keep both the transmitter and receiver at 60 seconds. Once you're finished modifying the parameters that you wish, we can save the file and navigate back to the root directory. From here, we can open up the start experiment script and decide what experiments we want to run with this. In our case, we're only going to be running the radio side, so we can uncomment the start radio line in order to execute it when the start experiment script is run. Now we can run the start experiment script on both of the nodes. On the transmitter output, we can use screen-r radio to see what's going on. However, on this side, there isn't much output to really view. On the receiver side, we can do the same command, screen-r radio, and we can see some more meaningful output. To close the screen without stopping the script, we can use Control-A-D. In a moment, we will see on the left that the screen will terminate on its own due to the 60-second duration that we had set. It's important to stop the experiment afterwards, even though the screen terminated on its own. Now, if we take a look in the results folder, on the transmit side, we'll look at the most recent log. In this case, there isn't anything to really be viewed, given that the transmitter doesn't produce output. On the receiver side, there are three new files that we can look at: radiolog, tsout, and just out.txt. If we take a look at the radiolog, we can see the time-stamped output from the GNU Radio output that we had just performed. This file is generally very large given the grlog info message that we are getting here that generally points to potential errors in packets. However, when we look at the actual output data, we'll see that the outputs are far fewer than this file initially indicates. Hidden in between these GNU Radio info messages are outputs of the SNR at various times. We will use a post-processing script in order to extract this data more effectively. Next, let's take a look at the out.txt. By default, the transmitted file for this experiment is an incremental counter. As we can see, these values increment by 1 with each sample. However, in some cases where we may have come across packet errors or failed transmissions, we will see that some of the values do not increment properly and that there's some that did not complete the entire value. Similarly, if we take a look at the tsout result file, we should see very similar data that is now timestamped. And we can see that the same 873 that was shown in the out.txt file is present.